Hello and welcome back. Build Stuff 2021. Welcome back to the Saturn stage for our last 3 talks of the conference. And we've got 3 amazing talks to come up. First up, we have Henning Schwentner, who I'd like to invite to the stage now. Hello, Henning. How are you?
Hello, Stace. I'm fine. How are you?
I'm not doing too bad, thanks. Where are you calling from today?
I'm calling from the northern part of Germany now, from Hamburg.
Awesome. And is the weather outside as nice as it looks in the picture today?
No, to be honest, not.
Oh, bad luck. Okay, well, I won't take too much of your time, so the floor is yours. Henning, take it away.
Okay, Stace, thanks a lot. And yeah, the joy of multiple models is the talk that we're going to look into. And good afternoon from my side. Now, I hope the lunch break didn't make you too tired. And first of all, you heard it already. My name is Henning Schwentner, and as you can see here, I've just read the perfect age, the answer to all questions, 42. There's all downhill from here, fortunately. And I work as a coder, coach, and consultant for a company that's called WPS. So coder, that means when I'm lucky, I get my hands on the keyboard. But most of the time, I'm doing what I'm doing with you, working with software developers, with teams. On the one hand, as a coach, so I give a lot of trainings in software architecture, DDD, domain-driven design stuff. And the other part is consulting. That is, I work with teams on their monolithic old software, on their legacy software that should be modernized, that should be modularized, that should go back to a state where we can maintain it and where it's, again, fun to work with. And for me, as a technical person, it's interesting that you can build a monolith in virtually every programming language. So I see a lot of different technologies there. So you can see many Java systems and C# systems there. The languages are equally well suited for building monoliths. And then there's, of course, COBOL, the best suited language for building monoliths. Besides being coder, coach, and consultant, I'm also an author. I'm very proud. 3 weeks ago, my first book came out, was published. It's called Domain Storytelling. So if you never heard about this, you should Google it now, domainstorytelling.org. I will also show some of the things of this book during the talk. Yeah. As we saw, I work in Hamburg for a company called WPS, or Workplace Solutions. We're the one with the touch table. And for starters, I would like to tell you a little story of a domain, so that we can see how we build software for that domain and how a monolithic software for that would look like, or how a more modern, a more modular approach to that software would look like. So this is my father and 2 of my sons, and my father is reading a fairy tale to them. So, but I'm not going to tell you a fairy tale, but a story of a real domain, and this domain is auto leasing. How is auto leasing going on? If you want to have a new car, maybe because you said, well, my old combustion engine car, that stinks, and I don't want to have that anymore. I want a new electrical car, like this Porsche Taycan here, but you don't have any money in your pocket, then of course you can still go to your car dealer and ask them, do I get a car for this? And what you were expecting is, of course, they will tell you, well, no way, no money, no car. But this is not what's going to happen, because when you ask them, how do I get a car with no money? They will tell you, well, we have a solution for that problem, and that solution is called leasing. Leasing means, auto leasing means, car leasing means, we're not only having the car manufacturer and the end customer buying the car from the from the car manufacturing company, but now we get a leasing company in between. The leasing company will buy the car from the car manufacturer and then lease it, rent it for a monthly rate, for a monthly payment to our end customer. And let's look at this story in a diagram, in a domain story. So we have a customer here. and they tell their wish for a car to the salesperson. The salesperson will then calculate the installment for the contract. Installment means the monthly payment. That's the name for the monthly payment. And let's assume the customer says, well, yeah, I like that contract. I can afford that installment. I want to close the deal. Then they will sign the contract. The customer signs the contract. The leasing company hasn't signed yet. Both of them have to sign in the end. So the customer signs the contract, and then the salesperson passes on that signed contract to a risk manager. The risk manager then assesses the risk of this contract. That is, they check the credit rating, the risk of the customer, and then they calculate the resale value, that is the risk of the car. And based on this risk assessment, the risk manager will vote the contract. To vote means say, yes, we're going to make that contract, or no, the risk is too high. We reject this contract. We're not going to make that. Let's assume the risk manager voted the contract positively and says, yes, we are going to make that deal. Then the salesperson can give the car to the customer. What you see here, this diagram is what we call a domain story. An artifact coming from domain storytelling. The idea of domain storytelling is that we let our domain experts tell their story, thus domain storytelling. And while they tell their story, we draw a diagram out of that story to show our domain experts, this is what I have understood from what you have told me. So we can get rid of misunderstandings. That is the goal here. And we can use domain stories to understand the domain and then build software for it. That's what we're going to do today. So how can we build software out of a domain story? There's two rules of thumb here. I go back to the whole picture first. The first rule of thumb is we look at the work objects that we find in this story and make classes out of them. And then we look at the activities and make methods out of them. What are work objects and activities? When we look into a domain story, there's basically three elements, two kinds of icons and one kind of arrow. And the first kind of icon are these stick figures here. Those are called actors because they do something, they act in this story. And the other icons are called work objects. Those are the things that our actors are acting on. And then we have these lines here, these arrows, and those arrows are called activities. What the actor does with the work object. And now to our rule of thumb, we take the work objects, make classes out of them. We take the activities, make methods out of those. So that means when we look more closely in step 3, for example, the customer signs the contract, and step 7, the risk manager votes the contract. And we see contract, that's apparently an important work object in our process. So let's build a class out of this contract. So we build a class contract here. If you're familiar with DDD terms, domain-driven design terms, then this is an entity in the sense of DDD, because the leasing contract has an identity. But if you're not familiar with DDD terms, that's quite okay also. This is a class leasing contract. Second rule of thumb is we look onto the activities, so sign and vote. That's what the customer and the risk manager are doing with the contract. So sign and vote become methods in our class here. So what we then get to is what we call a domain model, because we're modeling the domain, the real world in the software, and we're saying this is a domain model with rich behavior. Because not only the name, not only the class is coming from the domain, but also the methods, the behavior. And this is great, what we get here. It's the first idea of object orientation in the end. We take the objects from the real world, make objects out of them in the software. This is a good idea, and it is not enough. That's important here. Because what happens is what we can see here. When we drill down deeper into the leasing domain, then we will find that not only is the contract signed and voted, many other things happen to it as well. It will be extended, it will be terminated, it will be sold to a refinancer, and so on. And what you can see here is it grows and grows and grows, this class. It becomes the one big model. That's what we hope for, at least. The one big model, the idea is, well, we're modeling this leasing contract in each and every detail. And then the hope is we can do with this model whatever we want. This domain model will solve all our problems that we have here. But there's also problems here. Because honestly, the one big model, that is what we think we get, but usually this is not what we really get. What we really get, and that's the sad truth, sorry, I have to tell you that, is that we get in reality not the one big model, but what we get is a mix of several mixed models. And that we end up with, that's a big ball of mud. All these different mental models that the different people that are working on bring together leads to a kind of software that's hard to maintain, that is easy to introduce bugs, and that gets error prone. So what we get is the big ball of mud, or the monolith, or the horror. That's what we hear there. Those are the names. So be careful with the one big model. Don't take my word for it. I'm not the only one who says that. I want to quote the late Karl Lagerfeld here, who apparently said, whoever uses the one big model, the canonical model, has lost control over his life. Well, I'm not so sure he was really talking about canonical models. Maybe he was talking about sweatpants. But anyway, it is true. Building the one big model is problematic and is usually an illusion. And why is that? Why is building the one big model so problematic? So asking this question, as Stacy wrote in the chat, I will have an eye on the chat. So if you have questions, just post them here into the chat and I will try to react on them directly. So, and of course, I want to win a Nintendo Switch too. But now back to our problems with models. Why is having the one big model, having the big ball of mud problematic? The problem is that the domain that we are building our software for is usually very complex. And high complexity means we have to understand a lot, because building software for a domain means we have to understand the domain. So we have to get all this complexity, all this domain stuff into our brain, into the brain of the developers. And that will lead to at least two kinds of problems here, because this domain is too big to be understood as a whole. We can't fit all of this at once into our head. And this will lead to problems. This will lead to errors, for example. The first problem is what we call whack-a-mole issues. Whack-a-mole, that's this game, what you can see here on a ferry market, where you have a board with holes in it, and there comes a mole out of the hole, and then you have a hammer and hit the mole on its head, and then it comes out of another hole and you have to hit it again. And the problem with this game is it never stops. You can't win, and there's only coming more and more moles out of the hole. And something similar is happening to every software system that exceeds a certain size. Software system that gets bigger, that crosses a boundary of size, will run into problems that are similar like this. And you probably know these kinds of errors. So you have a big system, an old system, and you get a new requirement. You get a user story in your hands, and that means you have to change that system. So you go to the system and you change a bit down here in the system. And then some evil bug comes up in a different part of the system, a part of the system that you didn't think about. That's the mole that's coming out here of another hole. And then you fix that bug here and something else happens up here. And then you fix that too. And when you're lucky, it stops. But only because you're lucky. Not because we knew in the first place what was going to happen. That's the problem with complexity, with big systems. You don't know in the first place what will happen afterwards, after you do the change to the system. That's why we want to have a small complexity, because for small problems, for small complexity, we can be sure or nearer to sure what will happen to our system than when the system is big. And this problem, these guacamole issues, of course, they will be more common the larger the system gets. The bigger the system is, the more guacamole issues will appear. That's why when you have a system, an old system, the older it gets, the slower the development becomes. Because every change you make makes the system even bigger, and that will lead to even more guacamole issues. When you start with a system on a green field, then everything is nice and easy. But then 5 years, 10 years, 20 years pass, and you end up with the big system which has these kinds of problems. That's one problem, guacamole issues. And another problem is what's called Max and Morris problems. Max and Morris, that's some kind of old German comic about two naughty boys, Max and Morris, who do tricks on the adults. And the first trick they are doing is they go to a woman, an old woman, the widow Bolte, which has chicken. And as you can see here, they took a loaf of bread and tore this loaf of bread into pieces. So we have small pieces of bread, and these small pieces of bread, they were tied together, as you can see here. And these tied together pieces of bread, they give to the chicken, and you can see the chicken, they swallow this bread, and then, well, the chicken are connected here with this thread here. And what you can see is the chicken cannot move without moving the other chicken as well. The chicken aren't independent anymore. And eventually they fly up and then they strangle themselves on the branch of the apple tree. And something similar is happening when you have more than one team working on the one big model. Every chicken is a team in that sense. And what you can see when you have the one big model, the monolithic system, the teams that work on that system, they cannot work independently. They have to work on the same thing. And Max and Morris problems, guacamole issues, okay. Apparently, those are problems that big systems have, and how do we get rid of them? So first we have to ask, what do I mean with this word model? I was talking about that a lot, this one big model. So for me, in this sense, a model is a tool to understand the world. That's important. So this is the world. This is our organ to understand, the brain. And the question is now, how do we put our head around the world? And what you can see here is the world is much bigger than our brain. And how do we get this world into our brain if it's much bigger than the brain? How can we understand it? Is that possible at all? And yes, it is possible. It is possible, although the world is much bigger than our brain, because we are able to abstract. human beings, are able to abstract. To abstract means we're only taking the essential stuff out of the world and we leave the inessential stuff out. Another word for that is to say we're building a model for the world. A model is a thing that only contains the essential properties of the world, and the inessential properties, they are left out. Okay, so we see a model is an abstraction of the world, and we see a good model does not exceed a certain size because it should help us to understand the world. So a good model is a small model. And also I said, well, we only want to take the essential properties out of the world, and the inessential properties, we don't want to care about them. But what are the essential properties? What is essential? That's, of course, the next question that we have to ask. And as a good consultant, I'm going to answer this question as a good consultant answers every question. They will say, it depends. And that's the same here too. And what does it depend on? What's essential? What's not essential? It depends on the context. In different contexts, we see that different properties are essential. And that means that we will usually not build only one model for the world, but that we want to build several models. So in the context where we use this globe, there we see as an essential property that the world is turning. So this is modeled in this globe here. That the world has a hot core, well, that's not modeled in this globe here. Other models for the world are maps. In this map here, for example, we do not model that the world is turning. We can't see that in this model. So it's not seen as essential in the area where we look, where we use this kind of model. On the other hand, what we can do here is we can see the world as a whole. We can see the whole surface, all the continents, and how they are related to each other. So two kinds of models, two models for the world, for the Earth. A globe is one, a map is another, and every other map that we can see here, that's also models for the world. This atlas, that is a collection of models. This is a collection of maps, and every map is one model for the world. For example, there are 5 pages of Africa, and all these pages are models for Africa. Page number 1, Africa geographically, Africa physically. That is, we see all the mountains and the rivers and the lakes, first model. Page number 2, Africa politically, there we can see the countries and the borders between that and the capital cities. That's the second model. And then Africa resources, page 3, that's the third model. There we can see ore mines and coal mines and whatever else resources are there. And we're not building the one big model, one map for Africa with everything, borders and countries and mountains and rivers and ore and coal mines, but we're building separate models for these separate things. So this is what we're doing in geography, building different models. So that's something that we don't have to do in programming only, but the idea of DDD, of strategic design, is to do that in programming, to do that in computer science as well. Not only do this in geography or in philosophy, do this in programming as well. And that means we have to do that with the domain as well. Remember, domain, that's the area of the world where we are building software for. And we were talking about domain models earlier. So we had this thing, we look at the things from the real world and we make classes out of them. By that, we were building a model, a domain model. And now we're saying we don't want to build only one model. We want to build several domain models as well. And to find out which domain models we have to build, we can look back to our domain story here again. And before we start building a domain model, it's a good idea to ask the question, where are the boundaries? So the idea is we look at the domain and see where are the parts of our domain, the subdomains of our domain. And for every subdomain, we build another part in the software. We build independent modules. So for example, I would say the steps 1, 2, 3, and 8, they form together a subdomain that we can see here, which might be called sales, for example. And then the steps 5, 6, and 7, I would say they form another subdomain, which might be called risk management or risk assessment. We'll have to discuss about that. And while in the old days, we would have built the one big model, the one monolithic system, now the idea is to say, well, let's not build one domain model anymore, but let's build two domain models here. Two bounded contexts, we also say for that. So there's things like the credit rating that only are in the risk management. We don't have a credit rating here in sales. We don't have a resale value here in sales. So the classes for credit rating and resale value, we build them only in the risk management part of the system, which is nice. That means the mental load of the people that work in sales, the developers that work on the sales part of the system, they don't have to care about credit rating and resale value. And then there's things that only are in sales. We don't have to care about them. Risk management, also nice. But then there's the contract, which appears on both sides. And what do we do with the contract? Well, that's the moment where we need to go to this point where we build several models, but we're not building the one big model anymore. So we are building for the contract several models. So that means we're taking this one thing from the real world, this piece of paper, our leasing contract, and we're not modeling it with the one big class contract anymore, the one big model, but we're building several models. So we're building one model where we can do the signing and one where we can do the voting. And we draw boundaries around that. And those are our boundaries that we found earlier in our domain story. So we have the sales and the risk management boundary here as well. And the idea is that we build these boundaries in our system as well. So we build our system now out of two modules standing beside each other. One module sales and one module risk management. Such a module is called in DDD terms a bounded context. Bounded because there's a boundary around, and context because that's the area, the context of one domain model, of one model that's living there. So we end up with sales and risk management here, and they both have their own idea of what a contract is. And what you can see here is their idea is a bit different. Sales looks a bit different on the contract than risk management does. Okay. And we do this with the whole domain. So the idea is we take this cow and cut it into pieces. We take the whole domain and cut it into pieces, and we have several parts which make up our system in the end. And we start with domain stories. We exclude these contexts out of them, and then it makes sense to get these contexts, these bounded contexts, onto another artifact. That's what's called a context map. Typically, we will not have only one domain story, but several domain stories, but we will have one context map, which gives us an overview of the whole system. So in this part, we see, well, there's one part of the system which is called sales and another part of the system which is called risk management. And there will be some connection between that. And this connection is an interface of blah, blah, blah. This is something that we would express in a map, which is called a context map. It used like landscape map. We want to put as a map of our system. And between these contexts that we find there, we want to have clear boundaries on different areas. Clear boundaries don't have to be as clear as here. We don't want to have a death strip. We don't want to separate people from each other, but we want to separate models from each other. And we're doing that on different levels. We're doing this in code. So we're building different models, different domain models, but we're also doing this in the database. So we are also building different data models. Every bounded context has its own domain model, but also its own data model. And then we can do it in the team level as well. That means we want that every bounded context belongs to only one team. One bounded context should not belong to several teams. Every bounded context should belong to only one team. One team may have several models, may have several contexts, but not the other way around. So the upper limit for the size of a bounded context, the upper limit of the size of a bounded context is, is one team. Should not require more than one team to implement one bounded context. So this helps us with this Max and Morris problem, right? There's several teams, they cannot work independent. We want to use that here. And this idea with this multiple models, that's called strategic design. The idea comes from DDD, from domain-driven design. And what we want is, we don't want to model the world as a whole, because we've seen what that leads up to, that we get this big ball of mud, everything is connected to everything. And when we analyze that with software, then we will get something like this here. So those are architecture elements here, and these architecture elements, they are connected with lines. And here in the middle, you can't even see the single line, because there's so many connections that we get a black hole. And black hole, that's not a bad metaphor for what we're doing here, because this big ball of mud gets a great gravity. Everything new is also sucked into this thing, and will also be part of this big mess that we have here. Okay, when we think about the domain as a cow, maybe that metaphor is not so great. I said earlier, well, we want to cut the cow into pieces, which would mean if we have a herd of cattle here, then we would cut them all into pieces, and we would have one team head and one team body and one team legs. And what you can see here, this is not only brutal, but it also has other downsides. So when we compare this to software development, this would mean we would make a horizontal cut when we organize our teams. So we'd say the head team, that's our UI experts, the body team, that's our business logic team, and the legs, and that's our database team. So that's a classical cut, layer teams. The advantage is we have all the experts together, all the head experts, all the UI experts, in a sense, or all the database experts there. But the downside is also obvious. This can only work if all the teams are there. We have this Max and Morris chicken problem. These chickens can't move independently from each other, because for everything that we want to do, for every smallest field that we want to add, it's not enough to just add it to the UI. We probably also have to add it to the database and to the business logic. So 3 teams have to work together to do that. And that's a problem, of course, because that means a lot of communication. That's why today we say, well, we want to organize our team in a more organic way, more like this. So every cow can live independently from each other. And that means we do the cut first on a horizontal way, on a vertical way. So we are cutting from top to bottom. We're cutting in bounded context first, and then inside of one bounded context, we're cutting the layers. And that also means something for team organization. This means for all these contexts that we have here, we have to bring all the experts together. That's why this works best with what's called a cross-functional team. So there's a connection to Agile, obviously, too. It means we're not making only the separation between these domain models here, contract for the risk assessment, contract for the sales. No, it's the other way around, a contract for sales, contract for risk assessment. But we're making this a vertical cut from top to bottom. That means sales has their own UI, their own domain model, their own data model, and risk assessment does so too. And only here in the middle, there will be an interface. In German, interface is called Schnittstelle, which means basically the place where you cut. And that's a good name when you think about this, because that's what we're doing. We're cutting our domain into pieces. And these interfaces, those are the places where we're doing the cut. Okay, so we want to move on from the one big model to several models. And there are different ways how you can implement these multiple models. When you're on the JVM, when you're using Java, then having two packages for the two bounded contexts might be the right thing. Or jigsaw modules might also be something to look at. When you're in .NET, having different DLLs might be the right thing. In PHP, we can use namespaces, well, which is not so much fun. And the general possibility is also to say, well, let's not build only two modules in one piece of software out of our bounded context, but let's make every bounded context its own program. Let's make every bounded context its own program. Then we would end up with a microservices architecture. So we're not building the one big monolithic system anymore. We're building a system of systems, and these systems, they communicate over a network with each other. Then every team gets their own microservices, their own software, and we can work even more independently. Microservices or self-contained systems or verticals, those are names that we can hear there. Okay. There's to say a lot more here, but we don't have the time for that. I want to give you some general advice to take with you. And I hope that, no, there we go. And talking about this last thing, well, microservices, that's one possibility, yes. But as a conclusion, what's important is the first thing we want to do is we want to model our domain. And then we want to split that domain up. So usually we don't want to build only one model, we want to build several models. And then you might want to think about distributing those models. That is strategic design, that's a must. Microservices, that's a can. Strategic design, you have to do that when the complexity is big enough, because you have to deal with that complexity, or otherwise you will run into problems. Microservices, well, it might make sense in your situations, but it also might not. So be careful with them. Don't just apply that pattern. Okay, coming to an end, further reading. 45 minutes is not a long time. If you want to look deeper into that topic, the Leasing Ninja, you can find it at leasingninja.io. That's a project of mine where I use this leasing domain to show how we can split this into pieces and how we can implement that in the end in Java, C# and other programming languages. And yeah, usually if I would be there in person, sorry, I am not, I would give away swag here. That's the official domain storytelling sticker. And talking about domain storytelling, if you found it interesting what I was talking about today here, domainstorytelling.org or domainstorytelling.org/book. There you can find the official book. And doing advertisement, I also want to advertise something good. So let's fight against blood cancer. If you're not, if you didn't do a typization so far, then you should do DKMS. That's the German variant for this, but there's other organizations in your country too. And by this, the end is near. I'm happy for feedback in the chat or so, and thank you. That's it.
Thank you. That was awesome. That was so much information whittled down into 40 minutes. We have one question in the chat, which is, how do we discover subdomains?
So thanks, Patrick, for the question. So I showed you this domain story where I said, well, you can see here are boundaries. It's obvious that the boundaries are here. And the truth is, doing that in a real world situation is, of course, hard. And you don't do that on your own. You have to do that together with your business. These domain stories, they don't fall from the sky. You have to mod them with your domain experts, with your users. And it's also with them to discover the subdomains. And the right question to ask here is, which activities, when we think about a domain story, is which activities belong together from the viewpoints of the actors. And then you draw boundaries around the activities and the work objects. And as you've seen, we don't draw them around the actors. And then there's only one heuristic to find subdomains. Subdomain finding can be pretty hard. DDD heuristics is also something that may help there. I'm going to post a link in the chat.
Awesome, thank you. Then I also had a couple of questions which came up when I was watching. In the model that you have for the leasing ninja, I noticed that number 4 didn't have a context around it. So how would you handle that particular piece of communication?
Yeah, gotcha. Thanks for that. Good point. Usually you would try to put all these steps into the boxes. I didn't do it because it wouldn't have fit nicely on the page that I did there. Also, what we have there, the step 4, that's maybe I find the slide. The step 4 that we have there, that's a special thing. That's this, I pass this contract on, and this is typically also an indicator, when I pass something on, that there might be a boundary here. So typically in a system, that this would be something where we have 2 parts of the system where we will have an interface and send an event or something like that.
Thank you very much. I'm sorry if I wasn't supposed to ask that question. It's
of course you are.
The other one which kind of comes on from that is, can it be that in these 2 domains you have overlapping models, and so we duplicate data on both sides?
Yeah. Thanks for that. That's also a very important point. It can be that we have this overlap in data, and we don't want to have overlapping models in the sense of that they have something in common. We want to put them nice and cleanly side by side. And that can mean that we have to duplicate data. And if we do, we have, of course, to take care of how do we synchronize that stuff? How do we get consistency for that? And when this is the first time that you hear about this multiple models thing, microservices thing, then you will, as a classical developer, say, oh my God, what are you talking about? This is the worst thing that you can do. Duplication, redundancy. Weren't we told that this is the worst thing that you can do? And well, kind of we were told that's right. For example, the dry principle that we learned from the pragmatic programmers, don't repeat yourself. That says we don't want to have redundancy, we don't want to have duplication. But this applies only inside of a bounded context. When we go over context boundaries, it can make sense to have duplication. And yes, that means we have to take care about, we have to take care of synchronization and so on. But for this price that we're paying, we're getting something else. And that's the one thing is we have this independence between the teams. And the other thing is we get models that are small enough to be still in quality, which is a problem for the one big model, which cannot be in good quality anymore, because everything that we're doing there, it causes these whack-a-mole issues.
Okay, thank you. And we're out of time, but I do want to ask the last question from Misos. How do you achieve loose coupling between the domains?
Yeah, so we achieve loose coupling between the domains by having two models, domain model here, domain model there, and having two data models, data model here, data model there. And then there should be no shared thing between these two sides. Then that means they have to communicate over a network, over an interface, and only over the interface. So we cannot access from the risk management, we cannot access the database from the sales, and the other way around. They are only allowed to communicate over the interface. So the only coupling will be to the interface, and that is the loose coupling. And inside the bounded context, we have on the other end high cohesion. And
okay.
I hope that answers your question.
Excuse me. Thank you for that. I believe you're going to be joining the Q&A chat. So if anybody wants to come and speak to you, they can go and join that Q&A chat and you'll be there and available. And for everybody else, we now have a break of about 15 minutes. So we will see you back here at 10 past the hour. Until then.
Okay, bye.